Okay, in this lesson we're going to talk about the order of operations. Our objective is going to be, as the student, I can evaluate numerical and algebraic expressions because I will follow the order of operations. That is the key to being able to evaluate both types of expressions. Okay, before we do this, let's make sure we understand what it means to evaluate. To evaluate means just to find its value. In other words, what does it equal? To use the order of operations to know what they are, that essentially they tell you which operation to do first. What I mean is this. Everyone is usually familiar with this phrase, PEMDAS, please excuse my dear Aunt Sally. Well, essentially this phrase, yeah, it's a mnemonic phrase to help you remember, but it helps you prioritize. Now, I drew those red dividers to kind of explain to you which one's on the same level. For example, P stands for parentheses. What that means is that's not just parentheses, that's any grouping symbols. So parentheses or brackets or even braces or those little squiggly bracket guys. And technically even absolute value. If you had something inside of absolute, those are supposed to be two bars, two absolute value bars. That's kind of like a grouping symbol as well. So parentheses or grouping symbols come first. E stands for exponents. At this point, you guys, I know you know what an exponent is. It's that little number up there, that 2. Well, in that case, I gave it a letter, but it would be a number if we're trying to evaluate it. Multiplication and division. Now, multiplication and division, they're in the same section, you notice, because they're on the same priority level. Essentially, if you have both multiplying and dividing in your expression, whether it be, at this point, you should be working with numerical expressions you plugged in for the letters. Anyways, you're going to go left to right. So things that are multiplying and dividing, if those are what you're trying to choose between in an expression, you're going to go left to right. So if they're within the same group, left to right. Same thing goes for adding and subtracting. With adding and subtracting, because they're in the same group, go left to right. So essentially, grouping symbols, exponents, multiply and divide, then add and subtract. Just make sure you go left to right when you're within the same group. That's the order of operations, and we're going to do some examples using that. Now, I gave you 2 examples here, and the instructions would simply just say something along the lines of evaluate each expression. So if you had 5 to the 3rd power and you wanted to evaluate, that means what does it equal? And I wanted to do a simple one first just to make sure review what it means to have a power. As a quick review, this little guy up here is called the exponent. The big thing at the bottom is called a base, but when you have them together, they're called a power. Essentially, the exponent tells you how many times you're going to multiply the base, aka the factor. How many times is it going to be you're going to have it to multiply by. All right. So for that one, that means we have 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 is 125. So if we were to evaluate that one, we'd have 125. Now, in the example right below it, we have 2 operations to worry about. We have subtraction inside of the parentheses, and we have multiplication on the outside. The order of operation tells us that we need to do grouping symbols before we can worry about multiplying. So let's do what we can do in the grouping symbols. So look inside the parentheses. There is something for us to do. We can do 8 minus 4. Well, we know what 8 minus 4 is. 8 minus 4 is 4. Now we can worry about the times 2. So now we can do the 4 times 2. And if we do the 4 times 2, we're going to get 8. And so that's the answer to this to that example. Now, this example on the top right of the screen, we've got a long expression, and I know it's kind of silly to have to see them written this way, but whatever, just so we get the point. So when we work through these, we're going to look for grouping symbols first. I see no grouping symbols, we move on to the next item. We're going to move on to exponents. So we're going to do exponents first. So 3 squared is 9, 2 squared is 4, and now that's all of our exponents. But before I go anywhere else, I'm going to drop down everything else just so we can see it on the line where it's nice and neat. Alright, so I just dropped everything down. Now what we're going to do is we're going to move on to the next step. After exponents is multiply and divide. They're on the same level, priority when I showed you, so we go left to right. So I see divided by 3, I see times 7, and I see divided by 5. So we're going to go through and do each of those, but in general, let's go left to right. So if we do divided by 3 next, 9 divided by 3 is 3. And then I see 4 times 7 in the middle, so 4 times 7 is 28. So that's going to give us 28 right there. And then we're going to have 20 divided by 5 at the end. 20 divided by 5, well, that's 4. So now we're just going to drop down everything else that we're left with. We already divided by 3, so plus and minus. Okay. So we've now dropped down everything that's remaining at that point. So at this point, we're now at the end of the order of operations, the addition and subtraction portion. Just do these left to right. And some of you may figure out sometimes you can do them in slightly different orders, but essentially just make sure it equals the same thing. So 3 plus 28 is 31. 31 minus 4 is 27. So that means when we evaluate that expression, we get 27. So this is just an example of working our way through and following the rules. And like I said earlier, it's not very often you're going to necessarily have an expression written like that example we just did. But if it ever did come up, you make sure it was an exercise, make sure you're applying the order of operations fully. We would generally write something like that with maybe some parentheses or some fraction bars or things like that to make it a little more clear. So speaking of fraction bars I just mentioned, look at this example. We have a fraction bar. We essentially have some expressions, some numeric expressions we need to simplify in the top and bottom of this fraction. So essentially what I want you to imagine is this. If you see a big fraction bar like this, dividing the top from the bottom, that's kind of like a grouping symbol. So if you want to think of it this way, that essentially is saying do the top, do the bottom, and then go ahead and worry about dividing. So think of that almost as like a grouping symbol, like I just drew with the blue parentheses. All right, so let's work our way through this. Let's do the top first. Up top, I see we have exponents. Exponents are going to come first, and so 4 squared, that's going to be 16. So now let's rewrite the top. Alright, so I went ahead and just drew the next fraction bar where we're going to show our next step. So we're focusing on the top of the fraction first, and then we'll come back and fill in the bottom of the fraction. Alright, so looking at the top, we've got multiplication, subtraction, and division. Now, multiplying and dividing comes first, so let's go left to right. 2 times 16 is 32. I meant to be using a different color. And then 8, we can't do the minus 8 yet. We got to do the 8 divided by 2 first. And 8 divided by 2 is 4. So that minus sign drops down. So essentially the top is just saying 32 minus 4. And then at this point you may realize 32 minus 4 is 28. So that means the top of our fraction equals 28. Okay, so now we've done the top of the fraction, we can now do the bottom of the fraction. So let's turn our attention to the bottom of the fraction. In that bottom, I see parentheses, so we need to do those first. Anything we can do inside those parentheses. We have 5 plus 2 inside those parentheses, and that's going to give us 7. So then we still have the times 2. So on the bottom, we only have 7 times 2 at this point. 7 times 2 is 14. And that doesn't necessarily simplify. We can't do anything else on the bottom, so that means the bottom is 14. So we are left with 28 over 14. Now it's time to actually finally do what the fraction bar says to do. 28 divided by 14, or 28 over 14. We're going to be simplifying that. So now 28 divided by 14 actually is even. It goes into it 2 times evenly. So that means the answer to this is 2, because that fraction would simplify to 2 over 1, which equals 2. So the value when we evaluated this full expression is 2. So now I'd like for you to try one. Press pause and give this one a shot. And I know this one may look kind of tough because it's got a lot going on, but think of it as with all those grouping symbols, like I see brackets and parentheses inside of them, just start from the inside and work your way out as far as grouping symbols are concerned. So press pause and give this one a shot. And once you do, hit play and I'll show you the answers. Alright, so if we go through the order of their operations, I already kind of wrote some of these in, kind of as little side notes. This isn't the ideal way to do it, I was just kind of squish for space. So, do the multiplication first for the 3 times 5 inside the parentheses over here. So 3 times 5 is 15, 16 minus 15 is 1, so that parenthesis is done. Now move over to this fraction over here. We're going to do the top. Gives us 15 over 5. Well, that whole fraction means 15 over 5 inside the brackets right here, so that's going to equal 3. 15 over 5 is 3. So we have 1 plus 3 inside the brackets. Well, that's 4. So we ultimately have 25 plus 4. Once you've done everything inside the brackets, you don't need the brackets anymore. 25 plus 4 is 29. Hopefully you got that one. If you made any mistakes, maybe think about what you did. Okay, so check out this example. This is an algebraic expression, and that's simply because we're starting off with letters and not necessarily numbers. And some of them could be numbers, but if you got a few letters and you need to plug in for it and then evaluate, that would make it an algebraic expression. Now, what you're going to do is you're essentially going to plug in for each of these letters, plug in what they want you to plug in. So that means everywhere you see an A, you're going to plug in 8. Everywhere you see a B, plug in a 4. Everywhere you see a C, plug in a 16, and so on. So for our first line, that means, let's start plugging in for the C. Well, C is 16 squared, so 16 squared. And then b is 4, so that's 4 squared, plus, and now we have b squared again, so that's 4 squared again, over a squared, so that's 8 squared. So we just plugged everything into their spot. And usually I would sometimes encourage you to use parentheses when you plug these in, but it's okay if you didn't. It's just a matter of taking your time and making sure you, for these specific ones, it's okay if you use parentheses because there's nothing next to the letters. It's just them on the top or bottom of their fraction by themselves. Okay, so now we've plugged in for everything. So now order of operations, we got to do grouping symbols first. There are none, other than, like we said, Imagines fraction bar was kind of like a grouping symbol. So we got to do the top and bottom separately. Then goes on exponents. So we need to do exponents. We need to evaluate each of these. Okay, so we'll start with, I guess 16 squared, start with the harder one. Alright, 16 times 16, that's 256. Okay, so we have 256 over 4 squared is 16. And then over here on the top right, 4 squared is 16, 8 squared is 64. So this is what those first turn into. Now, starting here, before I go any further, if I were you, I would start simplifying some of these fractions. That way we don't have to deal with big, giant numbers at this point. So if you notice, all these fractions simplify down. So we're going to take our time and we're going to make that happen. So, for example, the top is 256 and the bottom is 16 of our first fraction. Well, we know 16 goes into 256 because we just did that to get the 256. We did 16 squared. So that one we can probably figure out already how to simplify it. So if we do that, 16 goes into 256 16 times, and 16 goes into. Actually, I should write that over to the side. Make you do that. Okay, so 16 goes to 256, so we're essentially simplifying by 16 is what we're doing to this fraction. Let's make it smaller so it's more user-friendly. Okay, so I'm going to come down to the bottom left. So that's going to give us 16 over 1 plus, now the fraction on the right. We got to simplify 16 over 64. Alright, and in that example, 16 also goes in both of these. Now, don't stress if you didn't realize it was 16 that went into these numbers. You can always simplify by 2, then simplify by 2, simplify by 2, how many times you need to until it's simplified all the way down. So don't stress if you didn't know that right away. That's not a big deal. Alright, 16, 16. Okay, so the top becomes a 1. The bottom becomes a 4, so that's 1/4. So we have 16 over 1 plus 1/4. And yes, 16 over 1 is known as 16. So now, there's two ways to do this, but the most basic, simple one is don't overthink it. We literally have 16 plus 1/4. Well, that's like saying a mixed number. So essentially, that's literally 16 and 1/4. So that's your answer to this question. There was no need to, in this case, because the left number was a whole number, there was no reason to worry about needing to find a common denominator or anything. Because if you did all that, you would end up with a rather larger fraction. You would have something like 65, because you would do, if you were trying to find common denominators, you would hit times 4, so the top would turn into 64, so you had 65 over 4, but then 65 over 4 would simplify back down to 16 and 1/4. My point is, I just wanted to let you know that if you have a whole number plus a fraction, you don't need to worry about finding common denominators, because that's literally what a mixed number is. A mixed number is a whole number plus a little bit of a number, a fraction of a number, so it's a 16 and 1/4. So this was an example of a algebraic expression, and I hope that you found it to be a review, especially regarding maybe reviewing some of your fraction skills for working on these. So this example hopefully gave you some insight. So I'm going to end the video here, but I just wanted you guys to know at this point you've now seen some examples of evaluating numerical expressions, and you've seen some examples of evaluating algebraic expressions. So make sure you have all these examples copied down so you have them ready to go to help you for reference and use them moving forward on your future assignments. Good luck.